Welcome to Astronomy Daily, the podcast that brings you all the latest news in space and astronomy. I'm your host, Anna. In today's episode, we have an exciting lineup of stories to explore. We'll discuss the first major lunar standstill in 18 years, unveiling a breathtaking celestial moment you won't want to miss. Next, we'll dive into the rich metallic landscapes of Mars, painting a vivid picture of the red planet's geological marvels. We'll also tackle the unsettling reality of space junk and its impact on Earth's ozone layer, a concern growing with the expansion of satellite megaconstellations. Shifting our gaze to Saturn's moon Titan, we'll uncover how wave activity might be shaping its mysterious coastlines. Finally, we'll explore how cosmic winds driven by supermassive black holes can alter the very fabric of galaxies. And to round it all off, we'll get an update on the latest developments at SpaceX's Starbase. So let's dive right in. This year marks a truly remarkable celestial event, the first major lunar standstill since 2006. This fascinating phenomenon will see the moon rising and setting at its most extreme points on the horizon. For skywatchers, this is a rare treat, occurring only once every 18.6 years. During a major lunar standstill, the tilts of both the Earth and the moon are at their maximum, causing the moon to rise and set at its highest and lowest points in its orbital cycle. To fully appreciate the grandeur of this event, consider the ancient sites of Stonehenge, Callanish, and Newgrange. These prehistoric monuments are thought to be aligned with the points of moonrise and moonset during such standstills, indicating the historical significance and awe that this event has invoked in humanity for millennia. The next standstill at its most extreme will be around the equinoxes in September 2024 and March 2025. For those eager to witness this spectacle, the best times include moonrise at sunset and moonset at sunrise, especially during a full moon. No need for elaborate equipment. Just a clear view of the horizon will suffice to observe the moon's dramatic path. So mark your calendars and be sure to look up. The lunar sky is about to put on a show you won't want to miss. The European Space Agency has recently unveiled a breathtaking image of Mars' Mawrth Vallis region, highlighting the planet's complex and metallic beauty. This newly captured scene showcases landscapes rich in iron, magnesium, and aluminum, creating a vibrant and rust-colored spectacle that tells a story billions of years in the making. Mawrth Vallis is particularly significant because it bears evidence of ancient water flow. The region's deeply eroded valleys and mineral-rich layers suggest that liquid water once roamed these Martian plains, potentially creating habitable conditions. This discovery continues to intrigue scientists, as understanding the history of water on Mars is crucial for piecing together the planet's potential for supporting life. With ongoing studies and future missions focused on similar areas, we inch closer to unlocking the mysteries of the red planet's wet past and its capacity to host life. A new study has quantified the alarming extent of pollution caused by defunct internet satellites. Thousands of satellites have been deployed into mega constellations to meet the growing global demand for internet services. However, when these satellites reach the end of their operational life and re-enter Earth's atmosphere, they disintegrate and release aluminum oxide particles that erode the ozone layer. This phenomenon poses a significant threat to the years of progress made in ozone recovery. The 1987 Montreal Protocol successfully curbed the emission of ozone-depleting substances like CFCs, leading to a shrinking ozone hole over Antarctica with full recovery expected within the next few decades. But now, the unexpected increase in aluminum oxide pollution could derail this positive trend. The study, published in Geophysical Research Letters, shows that aluminum oxide particles initiate chemical reactions between ozone and chlorine, leading to sustained ozone depletion. Alarmingly, the number of aluminum oxide particles in the atmosphere has surged eightfold from 2016 to 2022. This spike is set to continue as companies like SpaceX and Amazon plan to launch thousands more satellites. The ongoing and upcoming mega constellations are estimated to significantly elevate aluminum levels in the mesosphere, thereby posing a long-term threat to the stratospheric ozone layer, which shields us from harmful UV radiation. The researchers emphasize the need for immediate attention to this growing issue, advocating for sustainable practices to limit satellite-driven ozone depletion. The results underline the importance of balancing technological advancement with environmental stewardship to ensure our atmosphere remains protective for generations to come. Titan, Saturn's largest moon, features active lakes and seas filled with liquid methane and ethane. These otherworldly bodies of liquid are not only visually compelling, but also tell a story of relentless geological activity. Recent simulations by MIT researchers have shed light on how waves might be eroding Titan's coastlines, radically altering our understanding of this mysterious moon. By modeling terrestrial erosion processes and applying them to Titan's unique environment, the researchers determined that wave activity is likely responsible for shaping the moon's shores. This means that shorelines on Titan resemble those formed by waves here on Earth, suggesting a dynamic interplay between the liquid bodies and the wind-driven waves. These discoveries offer invaluable insights into Titan's climate, helping scientists better understand its geological history and atmospheric conditions. If winds are strong enough to drive these waves, they could reveal secrets about Titan's weather patterns and even its potential to support some form of prebiotic chemistry. A groundbreaking study reveals that supermassive black holes are generating powerful cosmic winds, capable of accelerating gas to astonishing speeds of over 10,000 miles per second. These black hole-induced winds don't just ripple through their galaxies, they fundamentally reshape them. By either fueling or stifling star formation, these powerful winds can have a dramatic effect on the galaxy's evolution. Imagine a quasar, a supermassive black hole surrounded by a disk of matter being pulled in by the black hole's gravitational force. The friction created as this matter spirals inward heats the disk, emitting intense radiation that can propel gas at unimaginable speeds. This process isn't merely a cosmic spectacle, it serves a critical function in the galactic environment. Depending on the circumstances, these winds can compress gas, leading to the birth of new stars, or expel the gas, preventing star formation altogether. Researchers now have a clearer understanding of how these fascinating mechanisms work, thanks to long-term observational data that captured these accelerating gases in action. This transformational insight adds another piece to the puzzle of how black holes interact with and shape their host galaxies, emphasizing the profound impact these cosmic phenomena have on the universe. SpaceX is busy at Starbase, preparing for its fifth flight by upgrading its infrastructure, including new office buildings and the construction of a second tower. Recently, Ship 26 conducted its first multi-engine static fire test at the site, marking a significant milestone. These enhancements, which also involve a new test stand, improved tank farms, and the development of Mega Bay 2, are designed to expedite vehicle testing and future launches. With a new parking garage and updated launch mount systems in place, SpaceX aims to ensure quicker turnarounds and increase safety for its employees and operations. These ongoing upgrades showcase SpaceX's unwavering commitment to pushing the boundaries of space exploration and innovation. That wraps up our episode for today. Thank you for joining me on Astronomy Daily. Don't forget to visit our website at astronomydaily.io for all our previous episodes and the latest space news. Remember to subscribe to our podcast on Apple Podcasts, Spotify, YouTube Music, and iHeartRadio, or wherever you get your podcasts. I'm Anna, and until next time, keep looking up.